Okay, so in the previous video, we saw 4 different examples, and I'm gonna take you back to what those examples were. We saw one example that had 2 answers, but they were nice, normal, neat answers. We saw an example that had just 1 answer. This one had 2 answers, but they were weird, irrational answers with square roots. And then this one had imaginary numbers, so overall these were complex answers. Anything involving I makes it overall a complex answer. So we have 4 different categories that we could end up with, and there's actually a way to find out before you even do the quadratic formula what type of roots you're dealing with and how many you're going to have. Okay, so value of the discriminant. We have 4 different scenarios here, and it's all based on the discriminant. So let me write the categories that we had here. We had 2 rational roots. That was the first example that we saw in the previous video. We had 1 rational root. We had 2 irrational roots. And then finally we had 2 complex roots. Okay, so I'm going to flip back to that previous video again and show you how we could have known. So here's the difference between all 4 of these answers here. It's not this, it's whatever's under the square roots. So this, we had a 196 under the square root. 196 is a perfect square. The fact that this was a perfect square is what made this a nice, neat, pretty number, which made these nice, neat, pretty answers. So in order to end up with 2 rational answers, you have to have a perfect square under the square root, and it has to be positive. Okay, so if our discriminant is positive and it's a perfect square, we will come up with these nice, neat answers like we did in example number 1. Okay, let's flip back to the one where we got 1. Well, here we only got 1 answer because there was a 0 under the square root. Okay, so a 0 under the square root is what we would end up with here. Okay, and I should actually, I'm sorry, we should trade these because this picture won't make sense. Let's make this one the 2 irrational, and we'll make this one the 1 rational. Sorry about that, I wasn't really paying attention to what I had over here. So 1 rational would be if your discriminant is equal to 0, because adding 0 and subtracting 0 doesn't provide you with 2 unique solutions the way this does. Okay, the irrational. The irrational, we had an example of 28 under the square root. It's a positive number, so we get real answers, but it's not a perfect square. So because this isn't a perfect square, this doesn't simplify, and I have kind of icky, irrational answers. Okay, so this is if I have a positive number, but it's not a perfect square. Okay, so that's what I mean when I say non-perfect. It's not a perfect square the way that other example was. And then finally our complex answers. The reason these came out to be complex is because I had a negative under the square root for that last example. So if my discriminant is negative, I am going to come up with 2 complex answers. Okay, so sample graph. I would have 2 irrational roots if my graph looks something like this. If I had a normal parabola went through, I would have 2 x-intercepts. They might be rational, they might be irrational, I don't know. You could have a different scenario where your graph is upside down. So whether right side up or upside down, this is a sample where you would have 2 different x-intercepts. Okay? 1 rational number would be if your graph looks like this, if it just perfectly touches the axis and then bounces off like that. And you could have a similar picture for an upside down parabola. And then 2 complex would be one of 2 cases. Either your graph is right side up, but it's completely above the axis, or your graph is upside down, but it's completely below the axis. So this would be a case where you never ever cross through the x-axis, so you wouldn't possibly have any x-intercepts. So that's what we're looking for. We are going to, for each one of these, find the discriminants. And by the way, the discriminant is just that value that's under the square root. So that's our formula. It's just that piece of the quadratic formula that's underneath the square root. Okay, so when we find the value of the discriminant, we'll write it right here so it's in sight. We're going to do that first and then classify which category it would fall into. Okay, so here, the discriminant, b squared minus 4ac, we can fill in the following values. Here b is 8, that's the number in front of the x. A is -5, that's the number in front of the x squared, and then C is -1, that's the number that's just hanging out by itself. So we could plug this right into the calculator. You've got 8 squared minus 4 times -5 times -1. To enter, we come up with 44. Okay, so what we want to do is see which one of these categories 44 falls into. It's positive, yes, but it's not a perfect square, so we fall into this category right here. So based on that, we know we're going to have 2 irrational answers. So this is part of my answer, but then also stating what type and how many solutions I'm going to have is also part of my answer. Okay, next example. Be careful with this one because it's out of order. B is always the number in front of the x, no matter what order it's in your equation. And then -4, A is always in front of the x squared, and then C is always the number hanging out by itself. Okay, so let's plug that into the calculator. -7 squared minus 4 times 15 times -4. That comes out to be 289. So again, that's the first part of your answer, is the actual value of the discriminant. It's definitely positive. Is it a perfect square or not? It actually is. 289 comes out even. The square root of that is 17. So it is a perfect square, which means I am going to have 2 rational numbers. Okay, so I think, yes, that's it. You could also have one of these 2 scenarios, so just keep this chart with you. The last thing I have here is all of the methods that we have used so far for solving quadratic equations. So this is the last one that we learned. Quadratic formula could always be used no matter what, whether it's factorable, whether they're complex answers, whatever.